This is lesson 10.2.1, problem 1023. In this problem, we're given four different equations, and we need to try to rewrite the equations into easier equations, right? So we want to write equivalent equations, and we want to have no decimals, no fractions, and we want to have smaller numbers because they're just easier to work with. And so when we're doing this, we want to try to find the simplest equation we can make. And once we've done that, then we need to solve for the x-intercepts, okay? So for question A, we're given 32 times 3x minus 32 times 5 equal to 32 times 7, okay? And when I look at this problem, I'm noticing that every single term is being multiplied by 32. So if I want to make this a simpler equation, I can divide every term by 32, and it'll stay equivalent as long as I divide every term by 32. So I'm going to go ahead and do that. All right, so these are giant 1s, so I'm left with 3x, another giant 1 minus 5 equal to 7. All right, and from here, you should be able to see how you can solve for x. So I'm going to let you do that, and I'm going to show you how to rewrite the next one. So on B, we have 9,000 x squared minus 6,000 x minus 15,000 equal to 0. Okay, so again, I want to rewrite this into an equivalent, simpler equation. So I need to try to figure out how I can make these numbers smaller. And I notice that 3,000 goes into each of these terms. Okay, so what I'm going to do is I'm just going to divide every term by 3,000. Okay, when I do that, I get that 9,000 divided by 3,000 gives me 3x squared. 3,000 goes into 6,000 twice, so I'm left with minus 2x. And then 3,000 goes into 15,000 5 times, so I'm left with minus 5, and all that equals 0. Okay, so now it's a smaller, simpler equation that looks a lot easier to solve, and I'm going to let you keep solving this. So, right, you can choose how you want to do it. If you want to factor it, complete the square, do the quadratic formula, however you choose to do that to solve for your x-intercepts. All right, on problem C, we're given 1/3 plus x over 3 equal to 10 thirds. Okay. So in this problem, I want to bust my fractions, okay? And so remember, to do that, we need to take a look at what's in our denominator and undo that. So I notice that all of my terms are being divided by 3. Okay, so I'm going to undo that division by multiplying every term by 3. Okay, and so what happens when I do that is I can make these giant 1s. 3 divided by 3 is a giant 1, so I'm left with 1 plus 3 divided by 3 here makes a 1, so I'm left with 1x. And over here, these 3's make a giant 1, so we have it equal to 10. And from here, you can easily solve for x because now you have a simpler problem to work with. So you'll want to do that. And then in problem D, we are given 2x squared plus 4x minus 2.5 equal to 0. And so what I don't like when I look at this problem is that decimal in there. All right, so we need to somehow get rid of the decimal. We could do like we did in problem 1022, the last problem, and we could multiply every term by 10 to get rid of that decimal. Or some of you may have noticed, to get that to be a whole number, we could also multiply everything by 2, and that would give us whole numbers. So I'm going to do that. And so I'm going to multiply every term by 2, so that gives me 4x squared plus 8x, and then negative 2.5 times 2 gives me minus 5. And so when I do that, now I have nice whole numbers, and it gives me a simpler problem to work with. And so now I can decide which method I want to use to solve this quadratic equations to find the roots. Okay, so make sure you go back through A, B, C, and D now that we've rewritten them in simpler equivalent forms, and go back through and solve for x.